Okay. So today we will start a new topic, that is regeneration in steam turbine. Okay. So what is the strength now? First, I have to see how many people are there actually. Yeah, they'll join. So is my screen visible?
Yes, sir.
Okay. So today we will start a new topic, that is regeneration in steam 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 cycles or steam thermal cycles. Okay, steam cycles you can say directly. There is no need to write this. Okay, so as we have already discussed, what is regeneration? Can anyone tell what we from the previous? This is by the way, this is also one method of
increasing
improving
efficiency.
improving the performance of steam cycles. Okay, so what we are doing in regeneration, can anyone tell? Because
Uh,
we have already studied regeneration in gas turbines.
हायर एंथैल्पी वाले मतलब टरबाइन से इंटरमीडिएट प्रेशर पे एक्सट्रैक्ट करके स्टीम को उससे फिर मतलब जो फीड वाटर है उसको हीट कर देते हैं सर, जिससे जो मीन टेम्परेचर ऑफ हीट एडिशन है वो इंक्रीज करेगा.
What can you again tell?
अ,
इंटरमीडिएट स्टेज पे क्या करते हैं?
मतलब कुछ पोर्शन ऑफ द स्टीम को एक्सट्रैक्ट करके उससे फीड वाटर को हीट करते हैं सर.
Yeah, you are right. So uh, what is your name actually? You have given exactly correct answer. What we do
सत्य.
in regenerative cycle, what we actually do, we extract some heat at intermediate stage of the turbine, and then utilize that steam in order to increase the that quality of the steam entering that exiting that what we in the open feed water heater. So what we do is in this by regenerative cycle, efficiency is increased. How it is increased? By exchanging the heat internally between the expanding steam in the turbine and the feed water before entering the boiler. So what we are exactly doing? So the quality of the steam which is entering to the boiler, we are improving that, so that less heat should be transferred to the by the turbine, and heat supplied can be reduced. Okay, so wait, I'll write the point. Regenerative cycle is used to increase the efficiency of steam cycles by exchanging.
Sir,
Yeah.
uh, in regeneration we have seen, means in gas turbine we just passing through heat exchangers, means, and
What we are doing
in
that?
this case,
In this case, we will extract some steam before at the intermediate stage of the turbine. We'll extract the steam, and then we will utilize it for further heating. Hello.
means here we can't go for the process that we done in gas turbine.
No, because exactly what happens now, the steam here you are in that gas turbine. What we are doing that after the exit of the turbine, that steam we are using. But in case of steam turbine, if the we are using the steam at the exit of the turbine, then it will be in the it is generally in the wet region, so it will cause the erosion of the turbine blades at the exit of the turbine. So that's why that steam we are not utilizing, and that steam will not have that much superior quality to heat the steam entering that entering to the boiler. So we are extracting some steam at the intermediate state of the turbine, which is having sufficient good enough quality, uh, which will generally in the saturated region, saturated vapor region or superheated region, and then we will use that steam to increase the temperature of the temperature and the quality of the steam entering the boiler. Okay, which I'll explain. Just it is the beginning only, so you will not get that much. So by exchanging the heat,
Sir, here also the intermediate pressure is in the is the GM of the both boiler and the
no, no,
condenser pressure.
there is a two case will happen in this case actually, in open feed water heater and in closed feed water heater. So that will discuss separately. You want to know the pressure will be same or not, na?
Yes, sir.
Yeah, the in open feed water heater we have to first that I'll discuss. First, we'll start between the expanding steam in the turbine and the feed water before entering the boiler. So what we are doing, we are extracting some heat. Suppose this is a cycle. Okay. So if the quality of steam is superheated, so what we will do, this is the exact. Okay. So we'll extract some steam at this point. Okay. Like this point we will extract. This is point 1, 2, 3. Suppose here it is 1 kg. So what we will do, we'll extract some stream at this stage. Suppose y kg we are extracting. So what it will remain 1 minus y kg. Okay, here after point 2. So we'll extract this, and the after this pump, the quality of steam is here. So we will use this to increase the its quality or its temperature. Okay, so what will happen if we will utilize this steam to here? So what will happen, the quality will improve. So what will 1 2 3 4 5 6, and this is point 0.7. So previously, if this is the you can say that regeneration cycle, and what is the normal Rankine cycle? Suppose we are utilizing same between that superheated region. This is 1 2 3 4 5. Okay, or you can so what will happen, heat here, heat addition will be, heat supplied will be H1 minus H5, but here what it is happening here, QS is H1 minus S7. So which one is a larger among these two cycle? This is a Rankine cycle, ideal Rankine cycle. Ideal case we are assuming Rankine cycle, ideal Rankine cycle with superheated entry to turbine. Okay, and this is the regeneration cycle. So among these two, in which case we have to supply more amount of heat, regeneration or Rankine cycle? Hello.
Yes, sir.
In which case we have, yeah, in Rankine. Why? Because in Rankine, from here we can see, suppose if we are not extracting the heat at intermediate state, so whole of the steam will expand to point 0.3, and then point 0.4 will be heat rejection, and then again pump will increase the pressure of the steam. So this H1 minus H5, this amount of heat is extra, we have to add this one. If we will draw this line here, so this amount of extra heat we have to supply. But if we are extracting heat and then increasing that, so what will happen, this only our heat quality of the steam will be improved, and the that enthalpy of the steam will also be increased, uh, because of which we will reach point 0.7, and we have to supply less amount of less amount of heat in the boiler region. So what will happen, because QS is less in case of regeneration cycle, so what will happen, what will happen to efficiency of the cycle? Since it is low,
Increase.
so what will happen, efficiency will improve. Okay, is it okay? Hello.
Sir, but
Yes,
turbine
sir.
might be hampering.
Yeah, it will be hampering, but the that in wait, I'll show you. So what efficiency is given by work net upon heat supplied. Okay, so heat supplied is decreasing, but you are saying that network will also decrease, na? So it will decrease, actually network will decrease, but the corresponding decrease in that heat supplied is much lower compared to the network output. That's why our efficiency is improving. Why it is improving? Because we already know that in case of steam cycles, that pump work is almost negligible. It is because of the VF, it is in saturated liquid region. Okay, so pump work is almost negligible. So if we are increasing the quality of the steam, so pump work is almost, you can say that it will increase very small. It will increase, but its increase will be very small, very small, but it will improve the quality. So that heat supplied, we have to increase is very that is heat supplied in the boiler, that will be decreased. So it will increase the you can say that pressure as well as the quality of the steam before uh, in the saturated liquid region. So it will improve that. Pump work, it is given by Bf into P boiler minus P. Previously pump work was given by here pump work will increase actually. What will happen, pump work Vf into P intermediate minus P condenser plus Vf into Vf, here we have to take off intermediate pressure, and here we have to take off condenser pressure. Okay, so into P boiler minus P intermediate. So this is almost negligible. This is very less. it will be around 2 to
No, sir.
3 kilojoule per kg. But this one will be little bit higher. It will be around 10 to 15, you can say that. So because of which quality will improve, and turbine work will decrease, but it will the simultaneous the total effect turbine work will also decrease. So the net work will decrease because turbine work minus pump work, but the corresponding net decrease is much is lower. That even though net work is decreasing, but the heat supplied which we have to supply from the boiler is much decreasing compared to network output. That's why efficiency is improving in case of the regeneration cycle. Hello.
Okay, sir.
You were asking something.
No, sir. Same thing.
Okay. So anyhow, in gate they will only ask question on the numerical part. Basically, they will from the last 5 to 6 years in gate they have asked questions on the open feed water heater. So there are basically two types of feed heater which we have which are employed in case of types of types of feed heater. Okay, so there are basically two types. First one is open feed water heater. Second one is the closed feed water heater. Okay, so in first one open feed water heater, so we'll first draw the diagram. Okay, suppose this is boiler, this is point 1. Okay, and quality of steam here is 1 kg. Suppose the steam is 1 kg. This is turbine 1. Okay, suppose we are extracting at intermediate y kg of steam. Okay, this is point 2. This is also point 2. Okay, so remaining 1 minus y kg will again expand. Here I am writing this turbine 2, but it is turbine 1 only. So what will happen? It is only turbine 1 only because only we are extracting. For that I am showing in turbine 2. Okay, so from here it will expand up to point 3. Here also it will be 1 minus y kg. Then it will go to condenser. From condenser heat will be rejected. It will come to point 4, and here also 1 minus y kg it will be there. Now after that this steam rejected from the condenser. Here it will be a pump actually. After that pump, so pump what will it do? It will increase the quality of the steam up to 5, and this at point 5, after the pump 1 minus y kg steam will enter the open feed water heater working at intermediate pressure pi. Okay, and this steam which we are extracting also is going through it. Okay, so in open feed water heater uh, in what is exactly a open feed water heater? It is actually uh, you can say that mixing chamber. It is a mixing chamber where high temperature steam from turbine intermediate, which we are extracting at a intermediate will be mixed with the feed water coming from pump. Okay, so mixing will happen only and only if both pressure of the mixing fluid, that is the intermediate steam, as well as the uh, steam which is been condensed, both of the pressure are same. Both the pressure must be same, only then effective mixing will hap- will happen. That's why we here we are providing the pump, because the quality of the steam which is coming out of the condenser, it is at a condenser pressure. So we have to first increase the pressure of the from condenser pressure to the intermediate pressure at the open feed intermediate pressure on which open feed water is working. So the quality of steam which we are extracting, it is also the it is also at a intermediate pressure. So only then the mixing will happen effectively. So this is a very important point. This may they can ask in 1 mark type of question, that the quality of the steam for effective mixing in an regeneration cycle, what it is required. They will mention open feed water heater. So they can ask the pressure should be same pressure at of both the intermediate turbine and the after the pump will be same, not same, none of these type of option they can ask. So this you have to mark that for effective mixing both the pressure has to be same, otherwise mixing will not be happen very good. Okay, so after open feed water heater, what will happen? The quality of steam will again improve. And here y kg and 1 minus y kg. So after mixing, we will get 1 kg here again back. And again, then we will supply through the pump. Okay, pump 2. It is pump 2. It is pump 1. So from 6, it will again improve to 7. And then this we will supply to boiler. Okay, then we'll draw the diagram. So it is a open feed water heater. Okay, 1 minus y kg. I'm just drawing that and quality of steam. This is entering. Okay, and from here it is also entering. It is y kg and it is in the condition 2. It is 5, and from here it is condition 6, and it is 1 kg. Okay, and it is at the you can write enthalpy 5, enthalpy 6, enthalpy 2. Okay, so if we will apply the energy balance here, so what will happen? What is the energy balance? Energy in is equals to energy out. Okay, so how much amount of energy is entering it per kg in mass in terms of kg? So energy entering,
IH,
yeah, 1 minus y into h5 plus y into
H21,
h2 is equals to
H6.
1 into s6. So from here we can calculate y, how much amount of heat which we have extracted out at the intermediate stage. Okay, so this is also very important energy balance equation you have to remember, because uh, in many a times they won't give how much amount of steam they are extracting at the intermediate stage of the turbine. So for that you have to apply the energy balance equation there, and from there you can find out. Hello.
Yes, sir.
Okay, so how will the diagram will look like? Actually I have already drawn it, but I'll again draw. in case of open feed water. Suppose we are assuming here, assume that quality of steam at 1 and 2 is superheated. Okay, so if it is okay, so this is point 1. Suppose we are extracting at this point, this is point 2, this is also at superheated region, this is point 3, and then again it will again feed water. So 3, 4, 5, 6, 7. Okay, so what will happen? Here it is 1 kg. Here we are extracting y kg, remaining 1 minus y kg. Here also 1 minus y kg. Here also 1 minus y kg. So y 1 minus y plus y. So here it will become 1 kg. Okay. Hello.
Yes, sir.
Okay. Did you get the diagram? This is the boiler pressure. This is the intermediate pressure at which we are extracting the steam. This is the condenser pressure. So what will be the turbine work here?
H1 minus H2.
Yeah. Plus.
1 minus 1.
Yeah.
H2 minus H2.
Yeah. Pump work.
1 minus Y.
Yeah.
H5 minus H4.
Yeah. Plus.
1 into H7 minus H6.
Yeah. What will be the heat supplied?
H1 minus H7.
Yeah. So based on this what we have studied, we'll try to solve the problems which in the previous year gate they have asked. Okay. So I think open feed water is more than enough, but we'll discuss the closed feed water heater also at the end, because they don't ask that problem. The only difference in open and closed feed water, wait, I'll second one is closed feed water heater. The only difference is that in mixing chamber, the pressure of both the intermediate steam and the and that pumped after pump we get na 0.5 condition steam, 0.5 condition steam is not same in this case. Only this is the difference in open and closed feed water heater, because in this we are giving different channels, this is the channel for that steam, and this is the channel for that air condition. So this will flow here only, and this will flow, it will in the form of tubes. You can you assume like that it will be like this one will be for condition 2, here condition 2 steam will enter, and above and below another pipe will flow, inside which quality 5 steam will be there, and then this condition 2 steam will wait, I'll draw here. Suppose this is a closed feed water heater, inside which you can assume that entire that steam at condition 5 it is coming. Okay, so that intermediate steam will flow through the pipe like this. It will have some different pressure, and inside this it is whole filled with you can say that H5 condition steam. So this is 2 point, so this is 6 point, so the pressure is not same. By we are two, these tubes are made of coppers, so we are tube where you can say that heat transfer they supply this heat to the surrounding steam, okay, and improve the quality. The only difference is that only. And I don't think there is any other difference between that. It is 1 minus y kg, here it is y kg, and here it is 1 kg. So same energy balance you will apply here also. You no wait,
Sir,
no, this we have to change actually. Yeah, hello.
no, sir, the one which is crashed, I had doubt in that.
Which one?
At 6, how is it 1
Yeah,
kg?
no, it is not. That's why I said that it is not same. That's why I cut it down. It is not same. Actually, what happens? Wait, I'll draw the diagram in this. Then we'll solve the numerical. So first we'll write the what it is. What does happens in the closed feed water heater? It is mixing. So in closed feed water heater, high temperature steam rejects the heat energy to the feed water, that is condition 5, without mixing between the streams. In the previous case, what was happening? Both the intermediate steam and the feed water both were first brought to the same pressure, and then they were allowed to mix. But in this case, since the pressure is not same, so these what will happen? They will not mix with each other, and they will work at different pressure, and by flowing through the tubes, they will transfer the heat. So what happened, as the two streams are not mixed directly, so they are kept at different pressure. Here I will draw the diagram. Suppose it is a boiler. From here it is 0.1, it is 1 kg. This is turbine. In previous case also it is turbine, one turbine only. For only that viewing purpose I have shown it is a turbine 2, but it is turbine 1 only. Okay, so it is turbine, and here at the intermediate stage we will extract y kg of steam. Okay, and remaining 1 minus y we will allow to expand. It will be condition 3. Okay, this is condition 2. Now these both is a closed feed water heater. Okay, so here it will go into the condenser, and then quality will increase to 4. And now after the pump 1, the quality will improve to 5. Okay, it will be 1 minus y kg only. Here also, here also, here also. Okay, this we will go here. Okay, and this will go here to condition 5 with 1 minus y kg, and here condition 2 with y kg. Okay, so what will happen? Its temperature will increase. Because it is not mixing now, so it will remain 1 minus y kg only. But it's its quality will improve. 6 it will happen, and here what will happen here? It will improve. It will be y kg only. Okay. After that, it will go to pump. From pump, it will increase the pressure of the y kg of history. Y kg in the mixing chamber here. Here will be a mixing chamber. So this remaining extract will come here, and then this y and 1 minus y kg will mix up, and here we'll get condition 9 6. So we will get here 7. Here we will get 8, and this 6 in 1 minus y kg, 8 y kg. Here we will get 1 kg. Okay. Hello.
Yes, sir.
So what will happen if we will apply the energy balance here? Close feed water here. Here will be y kg. Here we will get y kg, but condition 2, condition 7. Here entrance will be 5, 1 minus y kg, and here it will be 0.6, 1 minus y kg. So what will happen? Energy balance we will apply. Can anyone tell? Energy in is equals to energy out. So what will happen? How much amount of energy is entering the system and how much it is leaving?
H2Y.
S2 into y, yeah, plus
1 minus Y into H5.
H5 into 1 minus y is equals to how much it is going out?
1 minus Y into H6.
Yeah, S6 into 1 minus y plus,
1 into H7.
yeah, this will apply. From here we will get the how much amount of steam y it is extracted. I think it is more than sufficient till now, till gate 2022. They haven't asked any question in the closed feed water heater. All the questions till date they can if they will try to ask from closed feed water heater, they will only ask till here. I think so, because for the first time if they will give, so they will give that in this form only, to how much amount of steam is extracted. That is why they will ask to calculate, and that's all I think they will ask. Uh, till date they have all 7 or 8 questions they have asked in the gate in feed water regeneration. All of them are in open feed water heating only. So we'll do that problems only. Okay. Yeah, this is the question. Please try to solve. Hello. Hello.
Yes, sir.
Yeah, this is the open feed water heater problem. So everything is they have given, and just what they have asked is specific enthalpy at each and every point. I think they have given specific enthalpy of steam at the location 5 is this, and a specific enthalpy of saturated water at location 6 is they have given. If the mass flow rate of water entering the open feed water heater at location 5 is 100, then the mass flow rate at location 2 they have asked. Just apply the energy balance, you will get the answer. This question came last year only in gate 2021. 2021 they have asked 2 marks. Hello.
Yes, sir.
Has anyone got the answer?
Solving, sir.
25.2.
Yeah, it is right. Oh, wait, I'll draw the first diagram. Should I draw here only or should I draw in the separate page? Wait, I'll draw. It is simple actually. Just you have to first draw the TS diagram. You can draw from here. Yes, it is almost similar what we have discussed. We don't know the quality of the stream. Extracting at some intermediate pressure. 1, 2, 3, 4, 5, 6, 7. So point 1, it is this one. Okay. Point 2, this is the point 2. Okay. So here it is 1 kg. It is they have extracted y kg. You can take it as y kg here. Remaining 1 minus y kg you can get it from here. Here everywhere you will get 1 minus y kg. 1 minus y kg, and here again after the you will get 1 kg. Just apply the energy balance. Y into H2 plus 1 minus y into H5 is equals to S6. You have been given the enthalpy at point 2. What it is? 2624. At 5 they have given 226.7. At point 6 they have given 708.6. The only remaining variable is y. Just put the values, you will get the answer. Answer I'll write 25.2. Y we don't know value of y. Okay. H2 we know 2624 plus 1. Actually what they have given 1 minus, wait, we have to draw again. I made some mistake, I think so. Here 1 it is not given actually. They have given from here to here, na? What they have given, if the mass flow rate of the water entering the feed water at location 5. So here they have given actually 100 kg per second they have given. This condition we don't know. So actually we don't know the how much amount of actually it is entering the turbine. So starting only we don't know. Wait. Suppose entering here it is x kg, and here H5 they have given 100 kg per second. Okay, so how much amount of here suppose at point, so at every point at 3 4 it will be 100 kg only, 100 kg per second. So what will be remaining at point 2? X minus 100 kg. Okay, kg per second. So what? Just apply the energy balance here only. I'll draw that diagram here. 1, 2, 3, 4, 5, 6, 7.
Sir,
Yeah,
by initial method also we are getting answer.
yeah. That is also fine. But actually, I didn't knew the answer from. I didn't knew that initial condition. That's why I put 1. But you can get it also from here. But I thought they have given 100 for whole. That's why I was solving from that. So apply both the condition. I think you will get from that also. Wait, I'll try from that also. Suppose it is 1 y 1 minus y. So 2624 into y plus 1 minus y into, because I have also not calculated, minus y.
Sir, instead of using 1 minus y, I directly use 100 on one side and x on another side.
Yeah, that also you can do. But you can use x, but at point 1 we don't know the condition. So first, you can assume that x kg of it is entering into the turbine, out of which x minus 100 100 kg per second is been expanded, and the rest x minus 100 kg it is extracted at intermediate stage. Okay, so only they have given they have given the question the mass flow rate of the water entering at condition 5. So 3, 4, 5, all of them, they we were considering 1 minus y, so all of them will have 100 kg per second only. So remaining that you can apply here, you will directly get from here also. Any method is right, but actually I haven't solved, so I'm just directly doing this. 100 into 2 to 6.7 is equals to S6 is 708.6. From here you can get the value of x, and from what they have asked in the question, then the mass flow at location 2, when you subtract from the x, you will get it. What is the value of x you are getting from this?
25.2.
No, x you will get, I think, 125.2 here.
Means,
From,
I use another method.
yeah, you all of them are right. Just apply the energy balance only. You have to just apply the energy balance at here. You will get the answers. Okay. I'm using this one. I'm considering x kg is entering, and out of which 100 kg is going to the condenser, and x minus 100 kg is going to the is extracted at intermediate stage. So both of the that method are right. Try to solve this question now. Has everyone got the answer? Wait, I'll do that first. Otherwise, some of you have not got the answer. Three, 4, 5, 6, 7. Suppose we are assuming x kg here. Here 2 to 3 they have already given that. Here at they have given 100 kg per second. So this will also be 100 kg per second. This will also be 100 kg per second. and here will be x minus 100 kg per second. So from here you will get again at this point x kg we will get. So directly apply energy balance. So at point 2 we are extracting x minus 100 and enthalpy at point 2 what they have given in the question 2624. This is point 2 at 5. What is the enthalpy they have given 226.7 and they have given 100 kg per second. At point 6 what they have given here we will get x kg back. We just apply energy balance here. X into S6 is equals to 100 into H5 plus x minus 100 into H2. So x we don't know. S6 is what is the value of enthalpy at point 6? 708.6. 708.6 is equals to 100 into H5. What is the H5? 226.7 plus x minus 100 into H2 2624. After solving what will get the value of x 125.2 kg per second and what they have asked in the question this how much is it is being extracted. So x minus 100 25.2 kg per second we will get here. Okay, hello,
Yes, sir.
is it fine?
Yes, sir.
Okay, try to solve this question. Here you have to what you have to find the mass flow rate of the steam blade from turbine as a percentage of the total. Here you have to find this. Suppose here you have extracted y. Here is 1 minus y. Or suppose it is x kg is here. So x minus y you will get here. And how much you will get here? Y kg you have extracted. So x minus wait, something I am checking.
Sir.
Yeah, here suppose it is 1 kg. Here 1 y kg we have extracted. So 1 minus y we will get here. So we have to determine y minus 1 kg. Suppose it is 1, I am assuming. So we have to determine this ratio. Total amount of steam which is entering upon how much it has been extracted. That ratio we have to determine. Here also we have to do the same. Just apply the energy balance. in the feed water heater. Every condition they have given. Suppose this is the feed water. So this is the uh, point where feed water is working. So what they have given actually. Suppose we are extracting x kg here. We don't know the inlet how much it is there. Okay. So if they are assuming this is 1 kg, okay, and this is, they have only asked that x kg, x, what is the value of x, only they have asked. So 1 minus x it will be here. So 1 minus x, here also it will be 1 minus x, and here it will become 1 kg. Okay. So here this is the feed water heater, here it is working. So it's condition 2, here it is condition 4. Let, so just I'm writing this open feed water heater. So 1 minus, no, it is 5 actually, I think so. At 5 it is entering now. 5, no, 4 actually, 4. 1 minus x into h4, and here at 0.4 it is entering and leaving at 0.5, and here it is 0.2 it is entering, and x kg. So just apply energy balance. What is the answer you have got?
20.
They have asked in percentage, or yeah, 20%. Say it is right. Energy balance, just you have to apply 1 minus x into h4 plus x into h2 is equals to h5. So 1 minus x into h4, what is the value of h4? 175 plus x, we don't know, h2 2800, h5 700. When you will calculate, you will get x 0.2, and they have asked in percentage, so just multiply by 100, you will get 20%. Hello?
Yes.
Yes, sir.
Yes, sir.
Okay. Try to solve this. These two are different separate questions, 65 and 47.
Sir, previous slide once. Okay, sir.
Has anyone got the answer for question number 65?
$135.56.
135.
Yes.
No, I think you have done mistake there. Uh, it is actually mentioned in the question na, that 20% has been extracted. So I think you are doing mistake here. You have to dig here. This is point 1. So point 2 they are extracting. How much they are extracting? 20%. So here it is entering 100 kg per second. So 20 kg per second it will they are extracting 0.20% na. So remaining here how will get 80 kg per second. So you have to consider this. For 1 to 2 100 kg, and from 2 to 3 you have to multiply with 80 kg per second. Then again I think you have made mistake here. Answer is around 125.
Sir, 126.24 megawatt.
Yeah, it is nearer to that. Have you decreased that pump work also?
सर वो डिक्रीज नहीं किया.
इसका कंडीशन भी तो देना चाहिए, पहले देखना पड़ेगा. इनलेट इंटरमीडिएट एग्जिट ऑफ द टर्बाइन. Yeah, HF they have given actually, so you can use this also. Wait, we'll discuss this. How much you are getting? 126.24
24 सर.
megawatt, na? It is
हाँ जी
close. It is closer. Where we'll calculate, then we'll see.
सर. व्हाट इज द एक्चुअल आंसर?
Actually, I also don't know. I'll solve here only. Based on your answers only, I give the answer. When 2 or 3 people get the same answer, then
The second one is 7581.
second one is 75. How,
81.
how many of you have got 7581? 7.81 kilowatt, na? Okay, we'll see. So should I do first question? Wait, there only will do. So what they have given in the question? We'll draw the TS diagram. One, two, three, 4, 5, 6, 7. So here at the entrance they have said that 100 kg per second it is entering, and then 20 kg per second they are extracting here at the intermediate stage. Okay, so remaining how much? 80 kg per second will again expand from 2 to 3. Here also 80 kg per second. Here also 80 kg per second. And from here also, here it will get 100 kg per second, because 80 and 20 both are entering here at the open feed water heater, so it will increase. Okay, so what they have got net work output na in the question.
Output, yeah.
Yeah, work output in megawatts. Okay, So what will be the turbine work? It will be equal to turbine work minus pump work. So what is the turbine work we are getting? It will be 100,
124. Okay.
yeah,
Uh,
100 into H1 minus H2
plus
plus 80
80 into
into H2 minus H3. Okay. And pump, what is the pump work? It will be 80 into H5 minus H4 plus 100 into S7 minus S6. Okay. So we have to see the values. Intermediate, they haven't given the intermediate condition. They have only given the, okay.
So, sir, so are they asking only for turbine work?
I think they are asking for turbine because they should have given here HF value na, at intermediate pressure. At intermediate stage they haven't given the, they have only given the turbine, that boiler pressure, and they have given the condenser pressure. They haven't given any condition of the steam in the intermediate condition. Like we need the condition at
Or
0.6 na, it will be equal to HF at intermediate pressure. This we have to take. From that only we can calculate S7 by isentropic process here also. So that is, that they haven't given. So I think they only want the turbine work only. So this, they, I think they have neglected. So what is the, we'll directly calculate the turbine work only. So 100 into H1. H1, what is the value?
3486
3486
minus 2776
2776 plus
plus
80
8
into
27
277 minus, what is the S3? We have to first calculate, I think, because S3 we don't know. We have to first determine the quality. So what, since 1, 2 and 3 all are isentropic processes, 1, 2, 3. So we can apply directly S1 equal to S3. Okay. All are isentropic process only. These you can isentropic. So from here you will get what is the value of S1. S1 at superheated condition 6.6, and S3 SF plus
0.6
X into Sg minus SF. This we have to take at 9 kilopascal pressure. Okay, 6.6. So 0.6 plus X into
8.1
8.1 minus 0.6. What is the value of X you have got?
0.8
Point.
8 sir.
Okay, 0.8 is right. Now this we will put in that, so we'll get the enthalpy HF plus X into HFG, no Hg, they have given Hg minus HF. This also we have to take at 9 kilopascal pressure condition. So just put the values, we'll get how much S3 we are getting. Wait,
2094
so H3 is equals to HF plus X into Hg minus HF at what, 9 kilopascal pressure. So HF, what is the value of HF? 174 plus 0.8. What is the value of Hg? 2
25
2574 minus 174. So what you have got?
2094
2094 kilojoule per kg. Okay. Now just put these values there. You will get the answer. So what is the turbine work net we are getting? 100 into 3486 minus 2776 plus 18 into 2776 minus 2094. So what you are getting?
125.
Yeah.
0.56.
Okay.
Yeah.
Is everyone getting? Because someone was getting 126.24 and one girl was getting 135. Hello. Hello.
Yes, sir. Getting sir.
Yeah. Because I think you were taking 100 only at that from 2 to 3 also. That's why you were getting a different answer.
No, sir. I made a mistake while calculating the enthalpy. I wrote the wrong data.
Okay, okay, okay.
Sir,
Yeah.
here 4 to 5 is pump.
Yeah, 4 to 5 and 6 to 7 both are pump. This is pump 1, this is pump 2, but they haven't given the condition for intermediate stage. So I think they are asking us to neglect the pump over. If they
Can we go to previous question?
yeah, the,
Again, previous.
yeah,
Here, sir, on this TS diagram, here is means how pump locating.
pump they have done, they haven't given the pump, they have just given the enthalpies at the point. If they would have I think they in this condition also they have asked us to neglect the pump work, because if they would have given the pump work now, so diagram would have looking like this: here, then here, then here, then here. So they have only they have neglected the pump work here also.
Yes, sir.
Okay.
But here pump work might be included in their enthalpy.
Pump work, no, I have just taken the point. This is the point where open feed water is placed. Okay, at the here. So at the condition of the steam entering, just putting the energy balance. H4 is the condition entering here, H2, and rejecting at H5.
Okay, sir. Means here no pump.
No, I don't think so.
Okay, sir.
So question number 47, has everyone done? This is also, I think it is simple. Steam with enthalpy adiabatic turbine at steady state 10, it expanded at a point where enthalpy 1 point is extracted, remaining further expand to turn where. Yeah, it is same like above only. Here it is much simpler. Just you have to wait. I'll do this also. One, two, three. So what they have given in the question? 10 kg. At point 10 kg, it is going 1.5 kg per second. They have extracted here, remaining 8.5 here. So enthalpy at each point they have given. What is the enthalpy at point 1? They have given 3214. At point 2 they have given 292
2920.
2920. And at point 3 have they given? Yeah,
2374.
23. Just 2374. Just put these values and you will get turbine work they have asked na. So 10 into H1 minus H2 plus 8.5 into H2 minus H3. 3214
75.
2920 plus 8.5 into H2 2920 minus 2374. So 75. What is the answer? 75?
7581
One,
kilowatt.
Kilowatt. Okay. I think this whole question, one more, this is, try to solve this one. It is also simple, I think. Just it is a open feed water here they have given. Okay. So open feed water they have given. Just apply the energy balance here at the energy balance at open feed water heater. So energy in is equal to energy out. What is the energy entering this is there? So what they have given, turbine, suppose 1 kg it is entering. Okay. So zero point 0.2 they have extracted here, remaining 0.8 is 8 it is going here. Okay. Kg, kg. So this will be 0.8, here also 0.8. Before entering 0.8, 0.2, just apply the energy balance.
Option
0.8,
E.
yeah, 0.8 into H2 plus zero point 0.2 into H1 is equals to H3 into 1, because 0.2, 0.8, 0.2 will become 1 only. So enthalpy at every point they have given already. 0.8 into H2, what they have given? 200 plus 0.2 into H1, 2800 is equal to H3. What is the H3 you will get?
720.
720, na?
Yeah.
Yeah,
Yes, sir.
kilojoule per
720.
kg. I think this much only they will ask. They haven't asked any question in the closed feed water heater yet. So I think it will not do that part because only in the engineering services examination previously they have asked on the closed feed water. So in gate there is scarcity of time, so I don't think they will ask open feed water heater only numerical they will ask. We'll do one more problem, then we'll wind up the class today. Okay, so I'll write that question. The regenerative Rankine cycle having steam train at 200 bar pressure and 650 degrees Celsius and leaving at 0.05 bar pressure. Consider feed open feed water heater here. Okay, and we have to determine the efficiency, and that pressure of the open feed water heater or intermediate, you can say that pressure is 8 bar. Okay, I am writing the values of at a different pressure at 200 bar and 650 degrees Celsius. What is the enthalpy value? 3675.3 kilojoule per kg, 6.6582 kilojoule per kg Kelvin at 8 bar. Kilojoule per kg SFG. What is the value of SF? 20 no 2.0462 and SFG 4.6166, both of them kilojoule per kg Kelvin. Also VF is mentioned 0.00 115 meter cube per kg. Okay, and 0.05 bar pressure values are given. HF, HFG 137.89 and 2423.7, both of them kilojule per kg. SF, SFG and VF 2764, 7.91, 87 kilojoule per kg Kelvin, VF 0.0015 and 0015 millimeter cube per kg. So efficiency you have to determine. Okay. Consider steam entering it 1 kg in the turbine. Okay. I think problem is simple. Only what you have done. Just I have asked here at enthalpy in the, but I don't think. But they may ask you this type of question also, enthalpy calculation. Hello, has anyone got the answer? Hello.
Solving.
Okay. Here you have to consider pumper work also, because they have given, and all the values which are required they have given. It will draw the diagram. So this point we don't know whether it is superheated, saturated. That also we have to calculate. So
Which point is 2 point, sir?
yeah, point two we don't know. It is actually I have mentioned here it is superheated, but we have to calculate it whether it is saturated vapor or it is a wet. It is in wet region or it is in superheated. That we'll get only when we'll calculate the value of the dryness fraction. If it will be 1, then it will be saturated vapor. Less than 1 wet, greater than 1 superheated.
Sir, at point 2, it is superheated steam.
No, it is not. We have to calculate. I have just drawn the basic diagram that you have to
Yes, sir.
calculate.
1.79, sir. Dryness fraction.
Okay, we will see. We'll calculate. Okay, we'll start the problem now. At point 1, because it is in superheated region, so all both H1 and S1 both are given. What is the value of H1 there from the data you have got?
35. 3675.
3675.3 kilojoule per kg. And S1
6.6.
6.6582 kilojoule per kg Kelvin. Okay, so first we will apply the that isentropic condition because 1 to 2 and 1 to 3 both of them are in that only you can say that isentropic condition. So the because of isentropic condition, entropy will be same. Okay, S1 will equal to S3 also. So first we will do S1 equal to S2. So S1 we know 6.6582 and S2 for 8 bar pressure condition we have to determine SF plus X into SFG they have given directly. This we have to take at 8 bar pressure. So 6.6582. What is the value of SF? 2.0462 plus X into 4.6166. Okay, so we have to calculate it first. So that's 6.82. What is the value of we are getting after subtracting 4.612 X into 4.6166. Okay,
But dry stream, sir.
yeah, 612 divided by 4.6166. What is the value of X you are getting? So it is greater than 1, so it is superheated. Okay, so what is the enthalpy for superheated V? Cp is given in the question.
No, sir. It is dry
It's
stream.
not greater than 1. It is 0.99.
X equal to 1, sir.
0.99.
Yes, sir.
6.6582 minus 2.0462. So divided by 4.6166. Yeah, it is. Sorry.
Sir,
Yeah,
can we approximate it to
yeah. It
this
is.
two?
Yeah, it is 0.999. So you can approximate it is equals to 1 only. Okay. So what you will
Okay.
get? Now we know that HFG is given by Hg minus Hf, and for x equal to 1 dryness fraction we take that x equal to 1 we take the value of Hg. It is saturated vapor. Okay, so we will calculate this by from here. Or what is the value of enthalpy? Actually Hfg 20 Hg we don't know, 721.11. Actually it is like, much closer, so if we'll calculate that also in wet region, so it will almost come to Hg value only. That's why we are taking directly. Unnecessary, it will consume time. So if the value is much closer, then you can assume directly.
2423.
2769.11. So what is the value at enthalpy point 2? 2769.11. Or this is saturated vapor. Or if anyone else want, he can also calculate that also, considering wet. So only one or two value will, either you can take this or you can calculate this also, HF plus X into HFG. The answer will not affect much. 721.11 plus 0.9992048. So what is the value from here? You will get 27 something 6, and it will be 1 or 2 point only.
I took 0.99, sir. I got 2748.6.
No, take 0.999. What you have got? 27.
2767.062.
Yeah, take triple nine, point triple nine, because after calculation it is, we are
Yes,
getting
2767.062.
2767.062
062.
kilojoule per kg. So it is almost near. So you can take this also, or if you want, you can take this also, because 1 or 2 that kg can affect your that answer. If they will ask you about the that turbine work output, in that case you if the range will be like this, mm, 1 or 2 degree only, then it may affect. So when in efficiency, I don't think so 1 or 2 kilojoule per kg will affect. But in case of turbine work, if they will ask in the question, then you should consider this only, because of the range they give in the problem. Okay. Because
Okay, sir.
yeah, because if they will give if they will ask the question for turbine work, so if they will give range of 2767 to 2769, then if someone is getting using this one, you will get you can directly put this answer. But if they uh, uh, it actually I've written wrong here. 2766222767. So they might ask like this. So if someone has taken 0.999 closer to 1, so he will directly take Hg value. So in this that case, it will become wrong. You although your value is almost equivalent, but when they will ask for turbine work, then assume that as a wet steam only. Okay, and take this value for turbine work. In case of efficiency, it won't affect much, because we are taking the ratio, so that will not affect much in that case. Okay, so now we will enthalpy at point 2 we have calculated. Now point 3 we have to calculate. So 6.6582 into 0.4764, wait, SF plus X into HFG. This we have to take at which pressure?
0.05.
0.05 bar. So 6.6582 SF 0.4764 plus X into 7.9187. What is the value of X you are getting from here?
0.78.
Yeah. Now from here you can calculate the enthalpy at point 3. HF plus X into HFG. This you have to take 0.05 bar pressure. So S3 what you will get? 137.89 plus 0.78 into 2423.7. So what is the value of S3 you are getting?
1923.
2?
2028.
Yeah, 2028.29. Yeah, 29 kilojoule per kg. Okay. This you will get. Now for that pump work. Pump work you have, how we can determine first pump work. Pump work 1 we have been given at Vf into P open feed water heater pressure minus P into condenser pressure. Okay, so this we have to take off the condenser pressure Vf. What? 0.05 bar pressure Vf value. Okay, so what is the value of Vf?
100.
0.10005. So pressure will be at intermediate or open feed water heater will be 8 into 100 minus 0.05 into 100. This we are consider in kilopascal. Okay, converting bar into pascal by multiplying it by 100. So what we will get? Pump work 1. Hello.
0.799 kilojoule per.
0.799 kilojoule per kg. Okay, so pump work 1 is H5 minus H4. Okay, so H4 we do directly know. This we can take 0.8 also if you want. So H4 will be HF at 0.05 bar pressure. So it is 137.89 plus 0.8. This we will shift it there. So what is the HF we will get? 138.59.
138.59.
59 or 69, 8 to the 69 it will come, because 0.8 it will come. So what we will get? H5 138.69 kilojoule per kg. Okay, similarly we will determine pump work 2. What it will be? Vf at open feed water heater pressure. Okay, this we have to take, and P boiler minus P open feed water heater. So what we will get? What is the value of Vf at from the table? 00115 into 200 into 100 we are converting into kilopascal into 8 into 100. So what is the value we have got? Pump work 2.
0.221.
0.221. Okay, so this is S7 minus S6. Okay, 0.221. So S7, S6 we will take HF at open feed water heater.
I got 22.08
This we have to
kilojoule per
calculate
kg.
H. 200 minus 8 into 100 into 0.00115. Yeah, it is 22. You check that it is 22 point
Sorry, sir.
0
22.08.
plus what is the value of HF?
721.11.
721.11. So what we will get directly from here? S7 minus 721.11, 22.08. So S7 what we will get? 743.19 kilojoule per kg. Okay. So this is also we will write that for what is the value H4 we have taken. H4 is equal to H5 at 0.05 bar pressure. So what is the value of H5? 137.89 kilojoule per kg. And S6 H5 at open feed water heater pressure we have taken. So what is the value? 721.11 kilojoule per kg. Okay. So just now, where is the feed water heater installed in this? Here it is installed. Na? So what is the entry to suppose 1 kg here it is coming. So it is 1 minus y. Here we are extracting y. So 1 minus y. Here also 1 minus y. So if we will apply here open feed water heater. So y into H2 and here 1 minus y into H5 and what we will get here? S6. Okay, so all the enthalpies we are having, just we have to apply the energy balance here only. So what will get? Open feed water heater, y into H2 it is entering and here 1 minus y into H5 it is entering and we will get S6. Okay, so what is the value we are getting? Here y, so here we will get 1 kg directly. What is the value of y we will get after applying energy balance? Hello.
0.22.
Hmm. Plus 1 minus y into H5 equal to S6. So what is the value of y we are getting? All the enthalpies we know, 6, 5, 2, we already know. Or the only remaining variable is y. So after putting we will get 0.22. Okay. Now we have to what we have to determine? Enthalpy. Okay. So what is enthalpy? Not that efficiency. And efficiency is work net upon heat supplied. So what will be the net work? Net work equal to turbine work minus pump work. So turbine work we have to determine. Turbine work will be equals to 1 into H1 minus H2 plus 1 minus 0.22 into H2 minus H3. This will be our turbine work. What will be our pump work? 1 minus 0.22 into H5 minus H4 plus 1 into S7 minus S6. Okay. Just put the values and tell me what you are getting turbine work and pump work. Similarly, heat supplied. What will be the heat supplied? 1 into H1 minus S7. So just we will put the values 1 into what is the value of the enthalpy at point 1? We have calculated already 3675. 1 into 3675.3 minus what is the enthalpy at point 4 at point 2? 27
2767 point.
062 2767.062 plus 1 minus 0.22 into 2767.022. You can directly 2769 also. It won't affect in the in case of efficiency, but in case of turbine work it will affect because 2 kilojoule per kg range may your answer may go out of the range, so consider that also in mind. So 2767 minus what is the enthalpy at point 3?
2028.
2028, 2028.29. So what is the value of turbine work we are getting? Similarly, here you 1 into H1 3675.3 minus S7. What is the value of S7 we are getting? 743.19. 743.19. So you will get QS directly. And pump work, pump work we will get 1 minus 0.22 into H5 minus H4. What is the value of the enthalpy at 0.5?
138.
138.69. 138.69 minus H4 137.89. 137.89 plus 1 into S7. S7 it is 743.19 minus S6 721.11. So what is the pump work heat supplied you are getting? Just tell me the answers.
The turbine work 1484.57.
1484.57
kilojoule.
kilojoule per kg, yes.
So kilojoules, kg we have multiplied, no?
Yeah. Hello?
Kg we have hello?
Yeah.
Kg we have multiplied, no, sir?
Yeah, you can take kilojoule. It won't affect the answer. That I have only taken. Okay. No, actually, yeah, it's right. Fine. You can take this also. It won't affect the answer. Heat supplied. What is the heat supplied you are getting?
2932.11.
2932.11. Okay. And pump work?
22.703.
22.703. Okay. Now just these put the values in that. What is the turbine work
49.
minus pump work upon Q supplied? So turbine work we are getting 1484.57 minus 22.703 divided by heat supplied 2932.11. So what we are getting?
49.86%.
Yeah, 49.86%. It is the right answer.
We know the pump work using the W equal to minus integral PDV.
Yeah.
We know the pump work.
Yeah, we know, but we have to calculate the enthalpies first, na? We don't know the enthalpies. We just know that this point at the entry here it is saturated liquid. Here it is saturated liquid. 5 and 7 enthalpy we don't know. And after that calculating this enthalpy we have to multiply with how much amount of it is entering into the pump. So 1 minus y it is entering. So that we have to multiply here. And pump work is given by, because pump compressor turbine all work on open cycles. So for open cycles we already know that work done is given by integration VdP. So we have applied that only. So after integrating we will get what will get work done? V into P higher minus P lower. Okay. Hello.
Yes, sir.
Yes, sir. Sir, is there any probability to get such kind of problems in
No,
the
you won't get, but I have given you for that practice one. They won't give if they will ask you for the enthalpy, na, they will directly give you the enthalpies of each and every point, because in the gate exam you won't get this much amount of time to go for one problem. They will give directly the enthalpy of point 1 is this, point 7 is this, each and every point they will mention. And they will directly, in most of the problem they won't ask you to consider the pump work. they will ask you to consider that assume pump work to be negligible. So one part is removed for that. You have to only consider the turbine work and the heat supply. Okay. Don't worry. In most of the problem, if they will ask such a big problem, they'll give you enthalpy at each and every point. You don't need to calculate that. Just for considering the whole problem, I have given this problem. Actually, this problem was asked in engineering services examination. This is a ESE problem that was asked in 20 marks.
One problem, 20 marks.
Yeah, engineering services. It was a conventional type of paper where you have to solve the whole problem. So they asked this problem in that exam.
Oh.
So for only considering the entire concept, so that you can learn the entire concept. So that's why I've given you this problem.
Okay.
Okay.
Eh,
You have already. I've already shared you the type of question they have asked in the exam. Like this simple question they ask only. You can directly see.
So, sir, in engineering science exam, there are less number of questions.
But the syllabus is very vast actually. Suppose in a gate exam, they in power plant they only ask questions from two gas turbine or steam turbine steam cycles. These two only they will ask problem. They won't ask any problem in the from compressor, or I haven't seen any problem on the compressor for
Yes, yes, some problems are there, sir, compressor.
yes, some might they have asked, but mostly they from the last few year trends they only ask problem the steam power cycles only. So they know that you have to solve 65 questions in 3 hours. So based on that, they give all the values of relevant data to you.
Okay.
Is it okay? So I think that steam turbine is also finished now. Now we have to only do that compressor part. If you want that we should do compressor part, then we'll do, because I don't think so they will ask any question in that. Instead of that, we can do problems on other cycles like Carnot cycle or air standard cycle we can do. But anyhow,
Yes, sir.
we'll consider also that also, because the remaining 4 weeks are remaining now. 12 weeks will be there, so 8 weeks are completed. So we'll see what we can do.
Problems on air standard cycles.
You want that?
Yes, sir.
Compressor IMP formulas or that.
Compressor, I can give you the formulas, but compressor part is more important in case of the, I think that engineering services. They ask many questions on that. I haven't seen any problem on that compressor in that air compressors in the in GATE exam. If they will ask, they'll ask in thermodynamics part, like work done in the compressor, like all those. So that might have already been covered. Because multi-stage compressor, I don't think so they have asked any problem. I'll see, and then I'll see whether it has to be done or not. Okay.
Okay, sir.
Okay, then we'll stop the class here only. Okay, I'll share the slides of the Rankine cycle in that WhatsApp group. Okay.
Okay.
Thank you, sir.
Okay. Thank you. Is there any doubt?
Hello, sir.
Yeah.
Sir, the mock testers are not available in GATE website. Why, sir? Mechanical
What?
mock testers. Mock test.
That I don't know actually. That you have to ask, ma'am. That the coordinators who are coordinating that gate portal, you have to ask them.
Okay, thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay. Thank you.
Sir, these online classes are conducted by IIT Madras.
Yeah, NPTEL, that gate portal is conducted by IIT Madras, but
Only IIT Madras are remaining.
it is coordinated by IIT Madras, but the teachers like students who we are teaching, so we are from all IITs.
Okay, sir.
Sir,
Yeah.
means in previous 2-3 questions I don't know exact number, but few questions I saw on compressor. So can we do that only questions previous days?
Okay, we'll do. I'll give you the
Because
important formulas, and then based on that we'll do the problem. Because theory they don't ask, they'll only ask the problems.
because I don't know basics of compressor working. That's it.
Okay, we'll do that. But in the next class there will next week there will be no class.
Okay.
Okay. Okay then. Okay. Bye. Have a
Thank
Sir,
you,
nice
sir.
day. Yeah.
the question paper is prepared by organizing IIT or all IITs, sir.
Questions. Questions are prepared basically the organizing institute. Suppose this year who is the coordinator for this year GATE?
Kanpur.
Then the question paper will be prepared by the faculties of IIT Kanpur.
Okay, sir.
Okay.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you. Thank you.